All right, hello everyone. I'm really glad to be here. I was last at EDCON in 2017. Yeah. Who was here in 2017? Yeah, nice. It seems like a lifetime ago now, but anyway, glad to be back. All right, without further ado, let's get started. I probably have too many slides, but we'll see. So I'm going to talk about realizing the world computer vision by combining Ethereum with the Internet Computer. And to give you some perspective, Bitcoin appeared in 2009 and gave us digital gold. Ethereum launched in 2015 and gave us smart contracts. And then finally, the Internet Computer launched in 2021 and produced something that you can think of rather like a crypto cloud. It's a blockchain, but it uses a very different architecture, a lot of super interesting advanced math and cryptography. And you see these kind of innovations come about every 6 years or something. So what does this world computer do? Like, if you can combine different chains and you can add crypto cloud functionality, one of the things it can do is trustless multi-chain. So the Internet Computer can interact with other blockchains without bridges. You can build absolutely anything on it. So you could build a mass market social network that will run end-to-end in a decentralized way. You can assign Web3 services to DAOs, and not just in the sense that people vote on proposals, and if some bit of text gets enough votes, someone goes away with a backdoor key and implements the proposal, but with full automation. And you can integrate with Web 2. So it's a big potential game changer. And the Internet Computer is the glue that makes this possible. It has something called concurrent canister smart contracts, which, if you're curious, remain deterministic. And it gives you unbounded scaling and sort of crypto cloud efficiency and speed. And it's powered by this thing called chain key crypto. So the objective of the Internet Computer project and the Dfinity Foundation generally is to solve this sort of fundamental problem where Web3 still primarily runs on centralized technology. And that's where hackers head, regulators head, censors head, gatekeepers head, vested interests head. And generally, the continued use of centralized technology is at the root of most of the problems that occur. So, whoops, I think we've got a clicker problem. Let's try. Oh, there we go. All right. So we want to end what we might refer to as a kind of decentralization theater, where 99.9% of compute in the Web3 space remains on centralized tech. So, here's a typical architecture where Web3 is running on Amazon Web Services. And the problem is that the platform owner here, Jeff Bezos, is ultimately a controller of the platform. And the developer is also a kind of controller of the Web3 that runs there because it's their credit card that's been put into the service, and they get a username and password, and they can just go in and arbitrarily change data and content and inject malicious code if they want to. And that, of course, means that you can't run that Web3 under the control of a DAO because a DAO can't control what's running on Amazon Web Services. So the way this is solved is through the world computer. And this vision of the world computer is one which is all-encompassing, where actually in the end, every system and service that you can imagine, every single system and service you can imagine runs 100% on the blockchain. And this opens, has the advantages of removing those weak centralized points, but also enables new things like full automation with DAOs, where DAOs have complete control, there's no backdoors. The software updates, the Web3 software updates go through the DAO, the whole thing. So since the Internet Computer has launched, we've seen an emergence of quite an interesting ecosystem, and new things have become possible. So to get a sense of it, I don't know if you can see on the screen, yeah, you can, the address bar of this browser window. It looks like a traditional crypto exchange, like a CeFi exchange. But if you look in the web browser address bar, you'll see there's a sort of strange string of numbers. That's because what you're actually looking at is the address of a canister smart contract. And that canister smart contract is serving the user experience into the browser. So one of the tricks the Internet Computer allows you to perform is having a smart contract serve the dynamic user experience. And you can do this in a way where you have the blockchain pre-sign assets like HTML and JavaScript. And there's a service worker in the browser that's verifying something called a chain key signature. But this is an order book exchange. This is like a CeFi exchange. You've got market orders, limit orders, fill or kill. And all of this is happening on the chain itself. This is something called OpenChat. This is a on-chain, fully on-chain, 100% on-chain messaging, Web3 messaging service. And every chat message is a transaction. And all of the content's stored on the Internet Computer itself. So even if a message is video or an image, it's living on-chain. And of course, the user experience is being served into a browser, is also being served by smart contracts. And there are two especially interesting aspects of this service. One is that it runs under the control of something called a service nervous system DAO, which also upgrades the software. So it's more than just something where we vote on a text proposal. It's actually a decentralized operational framework where you can update a running Web3 service, a bit like Git is, and GitHub provides a framework for managing an open source project, if you want. The other interesting piece of this is that it's multi-chain, and you can do things like send crypto with chat messages. And in fact, your messaging account is a wallet, and that's leaning on the multi-chain capabilities. Okay. All right, so chain key crypto release timeline. So the Internet Computer's integrated at the network level with Bitcoin. Internet Computer nodes speak to Bitcoin nodes, and smart contracts on the Internet Computer are able to create Bitcoin transactions without having private keys. The chain key crypto signs the Bitcoin transactions. Of course, this is hidden behind easy-to-use APIs. You can just say, give me a Bitcoin address, receive Bitcoin, send it. The next phase is integrating with Ethereum, again at the network level. You're going to have bidirectional calling between canister smart contracts on the Internet Computer and EVM smart contracts on Ethereum. And this bidirectional calling will be possible without a bridge. So you'll only be exposed to the security concerns of two different blockchains rather than additionally being exposed to the concerns of a bridge. And that's a very, very big deal. It also removes all the latency and things like that. So I work at Dfinity Foundation, based in Switzerland. There's no company involved in the Internet Computer project. Established in 2016, research that began in 2015. We're a not-for-profit. We actually have, I think, the world's largest team of famous and well-cited cryptographers. Probably the biggest R&D team in crypto, and it's been running for years. About 270 plus people globally. So I've given you the sort of pitch about what it does. I'm going to try and run you through in the time we've got remaining how it works, and if we've got time, we'll do a quick Q&A. So Internet Computer isn't proof of stake. It uses something called proof of useful work, and that means that it uses crypto protocol to combine these things called node machine devices that are run by independent people and run from data centers all over the world. And here we go. These nodes are combined to create subnet blockchains, and that's how the Internet Computer scales its capacity. And these subnet blockchains are obviously host and replicate canister smart contracts, which I think I mentioned can run concurrently on a subnet, but it's done deterministically. And together, all these subnets are combined using chain key crypto to produce a single, scalable, and efficient virtual computer that hosts canister smart contracts. Oh, that was interesting. Okay. Yeah. So another aspect of the Internet Computer is it's what's known as an adaptive blockchain. It's the world's first adaptive blockchain. And that means that it's self-governing. So it has a DAO called the network nervous system that's integrated into its protocols. And again, this is a kind of operational framework. So there are no kind of centralized parties with backdoor keys or organizing miners to upgrade. This network nervous system is completely open and permissionless, and people submit proposals to it to structure the network, create new subnet blockchains, upgrade the protocol, and things like that. And through that, it just continually evolves. In the 2 years it's now been running in production, the Internet Computer blockchain has been upgraded more than 145 times. More than 145 protocol upgrades have taken place. And that's thanks to the sort of reduced friction of having a DAO integrated with the protocol that's actually able to upgrade the whole thing. For example, pushing out software upgrades to the actual node machines, devices that host the network. So capabilities, the network nervous system, if you like a kind of master DAO that controls the network, is also a DAO factory. It creates these things called service nervous system sub-DAOs. And this is a really rather recent development people are beginning to use now. And you can basically propose that you want something that's running fully on-chain to run as almost like a blockchain extension under the control of a sub-DAO that maintains its own microeconomy, of course. And it'll run things, something called a decentralization swap, where the governance tokens are swapped for other tokens with the community, and the DAO maintains control of the tokens received in its treasury. And that actually provides for all kinds of new Web3 paradigms where you can kind of founderize users by giving them governance tokens. Users can directly interact with canister smart contracts from any browser. So you don't need thanks to the way it works, you don't need like a local client to interact securely. You can actually directly interact with smart contracts, as you saw with the DEX. And you don't authenticate yourself with a wallet. You can build a wallet, but you actually authenticate using something called Internet Identity, which is integrated with WebAuthn. The key is stored on your device, like in your laptop or your phone, inside the TPM most modern devices have. And that'll actually create a session for you. So as you interact with the Web3 service, that's obviously generating transaction calls, right, remote procedure calls. That's hidden because you created a session. And this is where it gets kind of interesting. The results of these RPC transaction calls are signed by the blockchain using a single master public chain key. And that chain key will tell you not only that the transaction ran against the smart contract with the parameters provided and it produced that result, but that it hasn't been tampered with, and also that the blockchain is running correctly. And this magic is possible even though the node machine devices have different public keys. And as you can imagine, as this thing scales out, it gains more and more subnet blockchains, which are kind of invisible. These aren't like avalanche subnets. They're actually combined into a single blockchain. And this sort of thing that can scale in an unbounded way has a single 48-byte master chain key. And of course, the nodes don't have some private key or something like that. And when you actually interact, you're not getting back a single signature. It's a compound signature, but it's a chain key. Something else curious, the internet computer canister smart contracts can interact with Web 2 by something called HTTPS outcalls. And bearing in mind that this is being integrated at the network level with Ethereum, this means that Ethereum smart contracts will have the same functionality. And what happens is these canister smart contracts are run locally by the node machines, normalize the results. The normalized results are passed to consensus. And if consensus is reached, it's passed to the smart contract. And that supports Web 2 interactions and decentralized oracles and things like that. Arguably, you don't even need an oracle with this functionality. So this is where it gets really cool. So the chain key crypto framework that powers the internet computer has been extended so that canister smart contracts can create ECDSA keys. And again, they're ECDSA chain keys, so there's no private key. It's a sort of variation on threshold cryptography. And this means you can use a canister smart contract to sign pretty much anything. The other thing, of course, this makes possible is that the internet computer can enable canister smart contracts to interact with other chains without a bridge being involved, because the internet computer allows canister smart contracts behind the scenes to create transactions on other chains. So we use the integration with Bitcoin to create something called chain key Bitcoin, and this is hopefully going to see some use in Nagano soon. It gives you an idea what you can do. The internet computer, by the way, its nodes talk to the Bitcoin nodes, and they pull blocks, maintain the UTXO set to make it easy for developers. And chain key Bitcoin is just created with a trustless contract. It allows you to transfer Bitcoin with 1 second finality, an incredibly low cost, like thousandths of a cent. Okay, there we go. Whoops. There's a bit of latency here. All right, we're back. All right, let's see if we can do this. So the important thing, of course, for everyone here is that Ethereum integration is coming, and you're going to be able to call directly into the internet computer from Ethereum smart contracts. And that will provide dApps on Ethereum with access to things like decentralized, trustless web serving, unbounded scaling, incredible efficiency. So our aim has always been to find ways of making blockchain more efficient than traditional IT. And if anyone's curious about that, catch me later and I'll explain how it's technically possible. Another thing that's coming on the internet computer is AI. So AI is very much at the heart, Web3 AI is very much at the heart of where we're going now. And it's going to be possible to spin up AI models and call into AI models from Ethereum itself. So that's it. I kind of run out of time. We've got an ICP event tonight, so if you want to know more, please come along. If you take that QR code, you can get the Eventbrite or whatever it is form. And we'd love to see you there and talk more about Ethereum internet computer integrations and the things that are possible. Thanks.